The B-24 Liberator was built to fly farther, carry more, and survive longer than any bomber America had ever produced. It flew combat missions from England to Romania, from North Africa to the Ploesti oil fields, across the Pacific from island chains that barely existed on pre-war maps. By the end of the war, more than 18,400 had rolled off the assembly line, the most produced American military aircraft of the entire conflict. And it killed its crews at a rate that senior commanders refused to publish. Not in combat, not from enemy fire, from the aircraft itself. The Davis wing, the narrow, high aspect ratio design that gave the B-24 its extraordinary range, had a structural characteristic that engineers documented in 1941, that test pilots reported in 1942, and that the Army Air Forces accepted because the production schedule made any other decision inconvenient. When the wing failed, it failed completely. There was no partial collapse. There was no recovery. The aircraft folded. Crews called it the flying coffin. They weren't being dramatic. In 1938, the United States Air Corps issued a request for a bomber that could outperform the B-17, not replace it, outperform it. More range, higher speed, greater bomb capacity. The specification was ambitious to the point of being unrealistic given the materials and manufacturing knowledge of the period, but the Army wanted options, and Consolidated Aircraft of San Diego believed they could deliver. The engineer responsible for the solution was David R. Davis. His wing design was unconventional, a high aspect ratio aerofoil with an unusually narrow chord that generated exceptional lift at the cost of structural depth. In wind tunnel tests, it performed beyond expectation. On paper, the Davis wing solved the range problem in a way no competing design could match. The B-24 prototype flew in December 1939. The Army ordered it into production before the performance data was complete. By 1941, contracts worth hundreds of millions of dollars had been signed with Consolidated, Ford, Douglas, and North American. 5 separate factories across the United States were eventually building B-24s simultaneously. The scale of the program made it almost impossible to stop. By the time the structural concerns crystallized into something that demanded a formal response, there were thousands of aircraft already in service and tens of thousands of men trained to fly them. The people who raised concerns were engineers at Wright Field in Ohio. Their reports went up the chain. The response was not a redesign. The response was a revised loading restriction, a document that told pilots how much they could ask of the wing before it would refuse. The pilots were not always told why. To understand what the Davis wing was, you have to understand what a conventional bomber wing was trying to do and why it struggled. A standard thick-section wing, the kind on a B-17, was deep enough to house structural spars with significant cross-sectional area. Those spars absorbed bending loads. When turbulence pushed the wing upward or combat damage reduced lift on one side, the spar bent but did not break. The wing flexed. The aircraft continued flying. The depth of the structure was its margin of survival. Davis removed the depth. His wing was narrow from top to bottom, roughly half the structural depth of conventional designs at equivalent span. The aerodynamics were exceptional. Drag was significantly lower than the B-17's wing at comparable lift values, which translated directly into range. The Liberator could fly approximately 2,850 miles fully loaded. The Fortress, operating under similar conditions, managed around 2,000. That 850-mile difference made the B-24 the only Allied bomber that could reach certain targets and return. The problem lived in what engineers call the bending moment at the wing root, the rotational force applied to the point where the wing joins the fuselage. In a deep spar, this force is distributed across a large structural area. In the Davis wing, it concentrated. Every pound of fuel in the outer tanks, every bomb in the racks, every degree of turbulence added to that concentration. There was a second problem. The B-24's fuel system placed significant weight in the outer wing sections. This was structurally sound in level flight. In a tight turn, in a dive, in the violent evasive maneuvers that combat made necessary, the dynamic loading on the wing root multiplied. Test data from 1942 showed that under certain combinations of airspeed, loading, and maneuver, the wing could experience stresses that exceeded its rated limit. The rated limit was already conservative. Engineers knew it. What they could not fully predict was how the structural fatigue would behave across hundreds of combat hours. Metal that has been stressed and de-stressed and stressed again behaves differently than metal under a single load. Cracks that were invisible to pre-flight inspection propagated through wing spars over the course of a tour of duty. The aircraft that had survived 30 missions was not structurally identical to the aircraft that had rolled off the Ford Willow Run line. It was lighter in ways that were not on the maintenance record. The fold happened fast. Witnesses, the rare ones who survived in other aircraft, described a B-24 entering a steep turn, sometimes for no apparent reason, and then simply ceasing to be a coherent aircraft. The wings separated from the fuselage, the fuel ignited, the debris fell in pieces across a wide area. There were 10 men on a standard crew. The Army had the data on this. The question was what they chose to do with it. Subscribe if you want more of these. Here is what the chain of command actually decided. In 1943, the 2nd Air Division of the 8th Air Force, the B-24 Division, operating from bases in East Anglia, had a loss rate that exceeded the B-17 groups, flying out of the same command structure against the same targets. Some of that difference was tactical. The B-24 flew lower and faster than the Fortress, which exposed it differently to flak and fighters. Some of it was pilot familiarity. The Liberator was harder to fly in formation, harder to keep at altitude in the European cold, harder to recover from damage. But some of it was the wing, and the people who tracked the accident reports knew that. The Army Air Force's Accident Investigation Board processed structural failure claims throughout the war. The categories were deliberately broad: combat damage, unknown causes, catastrophic structural failure. The last category was rare in the official record, not because structural failures were rare, because attributing a loss to structural failure required a finding that implicated the aircraft, the manufacturer, and by extension, the procurement officers who had accepted the design. No such finding was made publicly. What happened instead was a series of operational modifications. Fuel loading restrictions were tightened, certain maneuvers were prohibited above specific airspeeds, maintenance inspection intervals for the wing root area were shortened on paper, though whether line crews had the time and equipment to comply was a separate question. Replacement aircraft arriving from the United States carried incremental structural reinforcements that were not announced or explained to the men flying older airframes. The men flying older airframes noticed. They noticed that new aircraft from the factory seemed to handle differently. They did not know why because they were not told why. A crew that completed its tour, 25 missions in 1943, later raised to 30 and then 35 as losses mounted, flew those missions in aircraft that accumulated stress with each sortie. The maintenance system was not designed to track cumulative structural fatigue. It was designed to find visible damage and repair it. The invisible damage was not being tracked because the tools to track it did not exist at squadron level, and the institutional will to develop them was not present at command level. The direct human cost is difficult to isolate from the wider casualty data of the strategic bombing campaign. The 8th Air Force lost more than 26,000 men killed in action by the end of the war. The 2nd Air Division lost a disproportionate number relative to its sortie rate during 1943 and early 1944. The specific toll attributable to structural failure rather than enemy action has never been formally established. The records that would allow that calculation were classified. Some have since been released. They confirm the conversations happened. They confirm the concerns were documented. They confirm the decisions were made by people who understood what they were deciding. The production line at Willow Run did not slow down. The B-24 flew until the end of the war, and in some air forces, well beyond it. India operated Liberators into the 1960s. The aircraft that survived did so because their crews flew carefully, maintained them obsessively, and were sometimes simply fortunate. The ones that did not survive left no record of what had gone wrong, because the evidence fell in fragments across occupied Europe or into the Pacific. Of the 18,848 B-24s built, fewer than a handful survive in airworthy condition today. The Collings Foundation's All-American is among them, a B-24J that flies air shows and memorial events, carrying the name of an aircraft that did not come home. Standing beneath the Davis wing, looking up at the narrow profile that gave the Liberator its extraordinary reach, it is difficult to see the flaw. It is just a wing, a graceful, efficient, purposeful wing. That is the dark part of this story. It is not that the B-24 was a bad aircraft. In most of the ways that mattered, it was a remarkable one. It reached targets that nothing else could reach. It flew missions that changed the shape of the war. The men who flew it knew it was difficult and dangerous, and they flew it anyway. What this story is actually about is what happens when an institution knows the cost of a decision, documents it internally, and then manages the knowledge rather than the problem. The Army did not lie about the B-24's structural limitations. It categorized them, restricted them, and absorbed them as an acceptable variable in an industrial war. The men who paid that variable were not consulted. If that kind of story belongs in your feed, subscribe. There are more of them.